Hi, welcome to Chapter 5, Core, from the Core textbook, Lesson B, Arithmetic Sequences. So this follows Lesson A on number sequences. So we'll take a look now at a formal definition of arithmetic sequences and how we can find a variety of values and the sequences themselves. So definition from the textbook states that an arithmetic sequence is a sequence in which each term differs from the previous one by the same fixed number. And we call that number the common difference. And we can find that common difference by taking one term, subtracting the term before it. So here's the term. Let's see if I can, sorry about that. So here's one term, here's the term before it, and we get the common difference, the difference between those two values. And n is the term number. So that's the term number, plus 1 is the term after that term. And n has to be an integer because we're talking about complete, like exact term numbers in the sequence. And an arithmetic sequence can also be referred to as an arithmetic progression. So if we have this sequence -7, -4, -1, etc., you can see pretty clearly that to go from one term to the next, you're adding 3. If we take that formal approach and take some term and then subtract the term prior to that, then we get the common difference d. So -4 is term n plus 1. So if we're talking about n being the first term, then n plus 1 has to be the second term. So then we're taking that second term, the second term here, we're subtracting the first term, and that should give us the common difference between them. So then we try that. So -4 minus -7 gives us 3. And we go on to the next term after that, which is n equals 3, which is term 2 plus 1. So we then get -1 minus -4, which is term 3 minus term 2, and we get 3 again. Do the same thing again with term 4. Term 4 minus term 1, 2 minus -1 is positive 3, etc. Okay, so if we're told if it's arithmetic, then you only have to do one calculation of that to get your d value. If you're unsure if it's arithmetic or not, then you have to maybe go through a couple just to make sure that it does follow that pattern. So we see that the common difference is that d value, which is just the difference between two successive values. And so that's part of what we're going to use to make up the term, or sorry, the arithmetic sequence. If you were to look at any 3 consecutive terms, you would find that the middle term is the average of the first and third terms. So if we go back up here, the 3 terms are -7, -4, -1, the first 3 terms. So -7, -4, and -1. We see that the difference between all of those is 3. And so they're saying that -4 is the average. So the middle term is the average of the first and third terms. Oops, and equals 3 here. So that is term 1. Here's term 3. So if we tried that, -7 plus -1, the average of those two, there's 2 values, so we're averaging them. So we get -8 divided by 2, which is -4. And lo and behold, that is what we have right there. Okay, so the middle term of any 3 consecutive terms is indeed, well, at least in this case, and probably for all other cases, because it is the arithmetic sequence, it is the arithmetic mean between, it's right in the middle between the 2 outside terms, the first and third. Therefore, it has to be arithmetically the average or the mean of those 2 terms. Okay, so now we want to look at the general term, and the general term is basically a formula that will generate each term in the sequence when we know the first term, the common difference, and the number of the term we're looking for. So that's the general term. So in order to find this formula, we start out with the sequence starting with U1. So U1 is the first term. The second term being that it is D, the difference between the second term and the first term is D, we know that U2 is U1 plus D. So we see here U2 equals U1 plus D. We know then that U3, the difference between U2 and U3 is also D. So U3 is U2 plus D. But we knew from before that U2 is U1 plus D. So if we were to replace U2 with U1 plus D, then we get U1 plus D, which is U1 plus 2D, which we see over here. U3 equals U1 plus 2D. Then the fourth term, which is U sub 4, if we know that that is U3 plus D, and we just previously found that U3 was U1 plus 2D, if we substituted U3 with U1 plus 2D plus D, we get U1 plus D plus D plus D, which is U1 plus 3D. So one thing to look at here then is that U4, well, in every case, the term number is always one more than the coefficient of the number of differences. So we see that here, of course, there's a 1. So between U2 and U1, there is one difference. Between U1 and U3, there's going to be 2 differences. Between U1 and U4, there's going to be 3 differences, etc. So the pattern continues. So in order to actually find any general term that you're looking for, U sub n, if you were to start with the first term, which is not always, but often given to you, you start off with U1, you add 1 minus the term number you're looking for times the number of differences. And then you add that on, and you will end up getting the term you're looking for. Okay, so the formula for the general term then is U sub n equals U1 plus n minus 1d. Okay, U1 is the first term, common difference is of course d, n is the number that you're looking for. So here's our first example. We're considering this sequence 87, 83, 79, 75, 71, etc. We want to show that the sequence is arithmetic. So we're going to start with the expression. We know it's un plus 1 minus un equals d. So we're going to show that it's arithmetic. We don't know that right now. So what we need to do is we need to take 83 and subtract 87. That's going to give us -4. Then we try the second term, the second sequence, the second set of subsequent numbers. 79 minus 83, again, -4. We could try it one more time just to be sure. And again, we get -4. So because the difference, all those differences are the same, then there is a common difference because they're all the same, they're common. So there's the common difference of d, so therefore d equals -4. Therefore, the sequence is arithmetic. So we have therefore shown that this sequence is arithmetic. B, we want to find the formula for the general term. Well, that's a little bit less challenging now that we have the common difference. So if we start out with this formula, this is what we use for the for the common difference for the arithmetic sequence. So UN, that's the general form. So we just keep that. U1, well, we know U1 is 87. So we write in 87 here. And we've got n minus 1 times d, and d is negative 4. And then what we can do is we can simplify this. We can distribute this negative 4 into this bracket here. And that would kind of simplify things. So we've got 87 plus, well, plus negative 4n. So I can subtract that off. So we got negative 4n, and then negative 4 times negative 1 is positive 4. And so then that gives us 91 minus 4n. So our general term for this arithmetic sequence is un minus 91 minus 4n. Okay, that's the simplified form. The general form would be kind of just there as well. Okay, so that's simplified. Okay, so now we're going to move on and see what the 40th term is. Well, for the 40th term, we know that n equals 40. So all you have to do is substitute 40 in for n in a formula. So u sub n becomes u sub 40. So anywhere you see an n, you're going to write in 40. So 1 minus 4 times 40. And 4 times 40 is 160. And 91 minus 160 would be around 69, I believe. Please confirm that for me. I'm trying to do some mental math here, and sometimes my brain isn't the best place to do math. Just kidding. So yeah, so that would be 69. The term 40 is 69. And we now we want to find which term for part D. We want to know which term. So n equals what? Which term is the sequence is negative 297. So again, we're going to start off with the formula. Okay, so we could start there. We could actually even, since we have the simplified form, we could start here. And un is the term we're looking for, so we can substitute negative 297 in for u sub n. That's the term we're looking for. And now it's just a matter of simplifying and isolating the n to find this value. So we're going to 91, we're going to subtract 91 from both sides. And 297 minus 91, we'll have to get out my trusty calculator on this one just because I want to be sure about this. So when we subtract 91 from both sides, we end up getting negative 388. And that equals negative 4n. We divide both sides by negative 4, and this would take care of the sign, thus informing us that the term number will actually be positive because it has to. You can't have negative terms. The first term is always 1, and then the second term is 2, etc. So we have to make sure that that sign is always positive, and we're dividing by 4, negative 4, sorry. And so that means that negative 297 is the 97th term. All right, moving right along here. We want to find k given that the consecutive, or given these consecutive arithmetic terms. So here we've got these terms. It's arithmetic, so that means that there will be some common difference. So again, we can use the same formula. N plus 1 minus u sub n is going to equal d. So we'll take our 2k plus 3, and we'll subtract our k minus 1. And so that's going to give us 2k minus k, and then plus 3 plus 1. That's going to give us k plus 4. So we can test that. Again, we can then do 7 minus k minus 2k plus 3. And so we're going to have 7 minus k minus 2k minus 3. And we're going to have then negative 3k plus 4. Okay, so we've got two expressions for d. And of course, since it's supposed to be a common difference, or if it's arithmetic, it is a common difference. So that equals d, and this is also equal to d. So if they're both equal to d, then they both have to equal each other. So we've got k plus 4 equals negative 3k plus 4. We subtract 4 from both sides. And so that disappears. So we're left with k equals negative 3k. We add 3k to both sides to get the k's all on one side. So we're left with then 4k equals 0. And of course, then k equals 0. So since that's the case, just to double check this also, before we mentioned that the first and third terms, the average of the first and third terms would equal the second term of 3 consecutive terms. So let's try that. Let's go through k minus 1 plus 7 minus k divided by 2. So we've got, when we add that together, k minus k is 0, so we're left with 6 over 2. So the average is 3. Therefore, that middle term, 2k plus 3, has to equal 3. And of course, we subtract 3 from both sides again. And so we're left with 2k equals 0, and therefore k does equal 0. Okay, so we found the value of k, which is k equals 0, and we found it in 2 different ways. So I'm pretty confident that that's true. So now we can just check to make sure that this will give us an arithmetic sequence. So if k equals 0, when we substitute that into the formula, then that means the formula, or the arithmetic sequence, is negative 1, 3, and 7. And we notice here that d equals 4 in both cases there. And then if you were to substitute k equal to 0 into the difference, the formula for the common difference, we get k equals 4, k is 0, so d does equal 4 in both cases, because k of 0, we do know that d equals 4. Okay, so we're trying to find k, and in fact, in 2 different ways, we found that k equals 0. Moving along now, we want to find the general term u of sub n for an arithmetic sequence. So we know it's arithmetic, so there will be some sort of common difference, with the 7th term of 1 and the 15th term of 39. So if we start out again with this form, u1 plus n minus 1 times d. So the 7th term is 1, so u sub 7 is going to be 1. So we got u1 plus 7 minus 1 times d. So we can replace the left side there with 1. And 7 minus 1 is 6. So we've got u1 equals, 1 equals u1 plus 6d. We do the same thing here for the 15th term. U sub 15 is u1 plus 15 minus 1 times d. So the 15th term is negative 39. So negative 39 equals u1 plus 14d. And then what we can do is we can do some substitution or elimination or whatever we want to do. So I'm going to write this under here. I usually like doing elimination. So I'm going to have negative 39 equals u1 plus 14d. And because I've got u1 the same in both cases, I'm going to subtract. And so that gives me 40 equals negative 8d. and divide both sides by -8. So D equals -5. So the expression then is UN equals U1 plus n minus 1 times -5. Okay, and then we can just take one of those, whichever one we like. I'll use the seventh term because it's a little bit easier. So I'm going to substitute 1 in here. We still don't know U sub 1, but the seventh term n becomes 7, of course. We substitute 7 in, so that gives us 6 times -5. So 1 equals U sub 1, sorry, minus 30. Add 30 to both sides, so U sub 1 is 31. So therefore, the general term is 31 plus n minus 1 times -5. And of course, we can simplify this a little bit by saying 31 minus 5n plus 5. So therefore, the general term is 36 minus 5n. Okay, so that would be the solution to that example. When we deal with real life problems, surprisingly enough, the real world isn't always exact with everything. So there's always like some sort of difference or approximation or whatever. So when we have to do something with real world examples, we need to kind of realize that there may be some sort of variation, and the formula will have to suffice, even though it won't be a perfect common difference between terms. Okay, so let's take a look at an example that could be similar to that. A farmer has 580 square bales of hay in his shed with total mass of 9,850 kilograms. The farm has 8 yards of animals, and each day the farmer feeds out 2 bales of hay to each yard. So if he's baling out 2 bales for each of the 8 yards, then obviously there's 16 bales per day. And we're going to have to figure out what exactly is happening here. So we want to write out an arithmetic sequence for the number of bales of hay remaining after n days. So in part A, we're going to come up with the arithmetic sequence. We know that the expression is U sub n equals U1 plus n minus 1 times D. U1, well, the first amount of bales of hay that we have is 580 plus n minus 1. And the common difference, well, if they're distributing out 16 bales of hay per day, then D, the common difference, will be -16 because the total number of bales is disappearing. So it's going to be -16. And so then we have, if we simplify this, 580 plus -16n plus 16. So that gives us 596 minus 16n will be the arithmetic sequence for the number of bales of hay remaining after n days. So for B, we want to know the arithmetic sequence for the approximate mass of hay remaining after n days. So if we know that there's 580 square bales of the total mass. So if we calculate the mass per bale, that's going to be 9,850 kilograms divided by 580 bales. Then as we do this calculation together, we get a value that is 16.9827, which is approximately equal to 17 kilograms per bale. Okay, so then, because obviously with the decimal, it's an approximate value when we substitute. So U sub n is going to be U1 again plus n minus 1d. If each bale is approximately 17 kilograms, then the difference in this case is going to be negative 16 times 17, because each bale is 17. They're getting rid of 16 bales per day, so 16 times 17, well, it's going to be negative 272 kilograms per day. So the general form, so there's 9,850 bales to begin, or sorry, kilograms to begin with, plus n minus 1 multiplied by negative 272. So we're going to have minus 272n plus 272. So I will take that and add it to 9,850. So the general term is going to be 10,122 minus 272n. Okay, so that will be the sequence that represents the approximate mass of the hay that's remaining after n days. Okay, so that is the lesson for today with the examples. Here's the work out of the core textbook, section 5b. Please start working on those questions, and thank you for watching, and we'll see you in class.